Again, we know that when we studied the first law, it gives us one property, that is internal energy, and we also studied the second law, which gives us the property entropy. So that means entropy is a property of the thermodynamic system. So what is ds is equal to dq by t. So it is very tedious to define the entropy, but it is very easy to define the change in entropy. We have seen unit of the entropy also. Okay? And during last lecture, we also studied why it is necessary to study the entropy. And we have ended with what are the entropy changes for different thermodynamic processes. Okay? So today we start with entropy of steam. Entropy of steam. So we know what is a steam. Steam is one of the most important working substances in thermodynamics, which is used in steam power plant or steam engines to achieve the desired effects. So now we have to study now the entropy of the steam. So before going to see what is entropy of steam, first we have to see what is steam, what are their properties, how steam formation is there. So we know that steam is formed from the water. Okay? When at any particular given condition the water is there, then when heat is supplied externally, that water is converted into steam. Suppose initially, and we consider the water is at atmospheric pressure, and we know that at atmospheric pressure boiling point of water is 100 degrees centigrade. And suppose the water is initially at 0 degrees centigrade at atmospheric pressure, then we start the heating of that water at the given condition, and we convert that water into, through different stages, into superheated steam. So that means we will start to heat the water. Initially it will absorb some heat, which is called as a sensible heat, and that heat is a heat absorbed by the water up to its saturation temperature at given conditions. If pressure changes, their boiling point changes. And after saturation temperature, the temperature remains constant, but phase change is there. So that means after saturation temperature, water boils and it starts to form the steam. So initially it is a 90% water is there, 10% steam is there. After some further addition of heat, 50% water and steam is there. After further addition of heat, all water is converted into steam, and at a particular point, that total water is converted into dry steam. So that means there is no any water particle suspended. Such a situation is called as a dry steam. If further that steam is heated by external heat, then that dry steam is converted into superheated steam. So the heat added from given condition to the saturation temperature is a sensible heat. From saturation temperature to dry steam, a latent heat of vaporization, and heat added further from convert the superheated steam from dry steam, it is a heat of superheat. So in this way we can convert the water into dry steam or superheated steam. So steam is the most important pure substance in engineering because it is used as a working substance in steam engine and steam turbine. Just now I explained. Now what are the steam is considered as a pure substance. So what are the most important characteristics of the steam turbine? Steam. So that characteristics are, first, it is a homogeneous in composition. So steam is pure substance of steam. Second, homogeneous in chemical aggregation. Homogeneous in chemical aggregation. Chemical elements must be combined. Chemical elements must be combined chemically in the same way in all parts of the system. So what do you mean by homogeneous in chemical aggregation? Chemical elements must be combined chemically in the same way in all parts of the system. This is second characteristic of the pure substance. Third, invariable in chemical composition. So there is no any change in chemical composition whether that pure substance exists in different phases, that is liquid, solid or gaseous. Invariable in chemical composition, we know pure substance exists in different phases. For example, solid, liquid, gaseous, there should not be change in composition at any phase. So that's why it is called as invariable in chemical. So these are some important characteristics of the pure substance. Now with the diagram, we can see how the, just now initially I explained how the steam formation is there. So with the diagram and graph, we can see how the steam formation process is there. Okay? So initially, we take this diagram. So initially we have taken one container where we are going to take a initial condition of initial water initially. Suppose we have taken 1 kg of water. We have taken 1 kg of water at 0 degrees centigrade. 1 kg of water at 0 degrees centigrade and atmospheric pressure. Okay, so we have taken there, suppose here a piston and cylinder arrangement is there. We have kept the weight over this. So initially we call this value as a Vf. So this is the value of water which is considered here. A cylinder and piston arrangement is there, and suppose we have started to supply heat externally to this container. Okay, so same consider. What happens after some addition of heat to this water? There is slightly change in value is there, but it is very negligible. That value is very negligible, and same amount of hot water is there. So here hot water is there. Okay. Now what happens after the further addition of heat? You further add heat to this. So partial evaporation process is there. Partial evaporation process is there. So that means some amount of steam and some amount of water is there. So here it is water is there, and here it is steam is there. So partial evaporation is there. So fully that water is not converted into steam. If we add further heat to this partial evaporation, then it will give us a totally dry steam. Totally dry steam. So this means this is a dry steam condition. Okay. If you add heat further to heated steam. Okay. So here we call this value. So that means this is a VR, initial value of water at given condition before we starting the heating. But when such a value is a VR, when we convert that water fully into dry steam, such a value is called as a Fiji. Such a value is called as a Fiji. And after the dry steam, that steam is a superheated steam, and that value is called as a FISU. So this is the simple procedure of the steam formation. Okay. So initially I explained how the steam is formed. So you understand. Suppose now the condition is 1 kg of water at 0 degree centigrade and atmospheric pressure. So initial value is Vf, value of dry steam is Vg, and value of superheated steam is Fc. Okay. So these are the different stages by which formation of steam will be there. Now, which amount of which type of heat is added there? Now we see with the help of this TH product. So TH product, TH, or we call it as total heat. H, temperature. Okay. Now you see, initial condition is a 0 degree centigrade of water. So initially we are here. Okay. So we started the heating. So this is the saturation point. If we add further heat, temperature remains constant, but phase change is there. And this is the dry steam line. And if you add further heat, this is the superheated steam. Superheated steam. So that means this is the curve which shows how the steam is formed from given conditions to superheat with the help of this graphical form. Here the initial condition of water is 0 degree centigrade. So that's why we have started that graph from 0 degree centigrade. And here this is 100 degree centigrade. Why is so? Because we know that boiling point of water or saturation point of water and atmospheric pressure is 100 degrees centigrade. Okay. Now this is a sensible heat. This is a sensible heat. So what do you mean by sensible heat? The heat absorbed by the water to start from its given condition to its saturation temperature is nothing but the sensible heat. This is a liquid point. This is the liquid point. So that means the condition of given water is at saturation temperature, but their state is a liquid. If you add further, the phase change process starts. And at this is a dry steam line. This is a dry steam point. So in between these 2 points, liquid line, liquid point and dry steam point, the heat added is latent heat of vaporization. Latent heat of vaporization. Phase change process. Here it is a liquid. Here the liquid is there. Here it is liquid plus vapor is there. And here the point which is a superheated point. Steam is superheated at this point. This point heat of superheat. We call this as a heat of superheat, and the notations, this sensible heat is called as Hg. This latent heat of vaporization is Hfg, and this Hg is equal to Hf plus Hfg, and here H sub is equal to Hg plus H sub. Now heat of superheat. Heat of superheat. Because after dry steam, heat is converted into superheat. Okay. So now this is the graph for the given condition. We know that saturation point changes according to their initial pressure. So that means if this given steam is not an atmospheric pressure, it is somewhat high pressure or low pressure is there, then that graph or that saturation point changes and the curve changes. Suppose same exerted pressure, if suppose water is at somewhat initially at 25 degrees centigrade. Suppose initially water is at 25 degrees centigrade. Then already some amount of heat is present into that water. Already some amount of heat is present into that water, and that heat we have to not supply. So after that additional heat is supplied. So that graph starts from, suppose initial temperature is 25 degrees centigrade and again pressure is atmospheric pressure, then this graph will come in this fashion. Because that graph will not start from this point, it will start from this point, because there is some amount of heat is present into that steam. So in this way, we don't know what are the initial conditions of water. It may be at some different temperatures, it may be at some different pressures. According to that, the nature of that graph changes, and you see that clearly. What is sensible heat? The heat added from initial condition to saturation temperature as per given condition is sensible heat. The heat added from saturation temperature to convert it into dry steam, that is latent heat of vaporization, and the heat added from dry steam to convert it into superheated steam, that is heat of superheat. So sensible heat denoted by Hg, latent heat of vaporization denoted by Hfg, and superheated heat is H sub, which is shown here by the H sub, and H sub is nothing but this Hg plus heat of superheat. So that we have to consider. Now suppose it is asked what amount of heat is required to convert this water into dry steam, then we have to calculate Hg and we have to subtract the initial amount of heat which is present from that total. So that means this Hg minus already which is heat present gives us total amount of heat present or required to convert the given condition of water into dry steam. So this is something about this formation of steam. Now in this way, if you plot the graphs for different conditions, and if you join their points, so what we call this line is a liquid line. So that means all these points on this line are liquid. Here is one topmost point, we call it as a critical point. We call this as a critical point. Okay. Now toward this side, all conditions are liquid points. Towards this side, all So in this way, we can form the steam from given condition to heat. So from this, we have to keep in one point that as the pressure increases, the latent heat of vaporization decreases. So you see that here the direct phase change is there. So that means at a critical point, there is a direct conversion of water into steam. There is no any latent heat which is required for that. Okay. So this is a simple procedure of formation of